The biggest reason that people struggle with the quantitative section on the GRE is that it really tests how you understand the concept. So if you're able to think of math as a concept, you're going to be able to do really well. Now, a really good example of this kind of thinking is in geometry. There are a lot of formulas that are really the only ones you need to know, but you aren't asked to plug and chug. Typically, you're not going to be given a lot of numbers. This is super true, especially in the comparison questions, and I'll show you one of these. Most of the time, we think of slope as the rise over run, but what exactly does that mean, especially with no actual numbers or calculations? Obviously, it's correlated to the steepness of a slope or how much the y value changes with the x value. If we're looking at a problem like this, we don't have any actual numbers, but we do have relative numbers. So the way that you can actually solve this is by looking at the intersection between the lines. The reason that we're doing this is because we know for a fact that x and y are the same, and it's a lot easier to compare when we have that. When we apply slope, we're looking at what happens when we change the x a little bit. At that intersection, if we move a little bit to the right, you can see that the change in line 2 is a lot greater than line 1. Most of the time, that's going to mean that the slope of line 2, because it's rise or the change in y, divided by run or the change in x. But because we have these negative slanted lines, that means that the slope is going to be negative. So we actually want a smaller change or a shallower slope. In this case, A is correct, and it's super simple if you understand what exactly slope means when you say rise over run. The other thing to know is that understanding the concept is also super important when you have a bunch of abstract variables. So a really good example is in algebra, this question. We know that A and B here are numbers, but we don't know exactly what numbers they are. We only know how to actually use them. The way that this notation is, when we have the two A and B numbers plugged in, A goes in the A slot and B goes in the B slot. So if we have M and N as the variables, the answer to this is going to be m squared times n to the fourth equals 5. The way that you want to think about this is that m squared and n to the fourth is one unit or one single number. When you have the actual question itself with 3m and 2n, you want to understand that plugging these in, you actually need to do just a tiny bit of math and you'll be able to figure it out. If we plug in 3m squared and 2n into that n to the fourth slot, make sure you know that that's going to end up being 9m squared and 16n to the fourth, because you have 3 squared and then 16 to the fourth. Once we have that, we can simplify further just by multiplying the 9 and the 16 to make 144. And then we're left with this kind of messy exponent structure. The nice thing about this is, as you can see, the m squared and n to the fourth is exactly the same as the value that we were given in the actual question. We know that that equals 5, so 144 times 5 gives us the correct answer of 720. What you need to do here is really just think of m squared n to the fourth as a single number, and once you do that and think about it conceptually or abstractly, the question becomes way easier. So try that out and good luck. Check out what my student Josh had to say about working with me. Visit my website or email me at alicechengre@gmail.com to learn more.